So now we're on halohydrin formation. So in halohydrin formation, what happens, it's very similar to halogenation, but you have this now, a different solvent. The solvent is water, or it's an alcohol like methanol, ethanol, you name it, any kind of alcohol. We learned in the table video that water and alcohols are weak bases and poor nucleophiles, but they still can be a base and nonetheless a nucleophile. CCl4 in the previous video, CCl4 is a solvent that does not have any basic or nucleophilic properties. My students ask me, how do you know? Just memorize CCl4 is not. They won't make it too difficult for a intro orgo course. Just remember, CCl4, it has no basic or nucleophilic properties, but if you have water or alcohol, any alcohol or water, yes. In fact, they say water or alcohol solvent, they put it in large, it's in the solvent, so there's a large excess. So the collisions of the water is increased versus the bromide ion. You could have had this as Cl2 as well, or another halogen, halohydrin, because there's, hydrogen, because you're adding water, halo like halogen, okay? So the mechanism is very similar. You form the triangle, Br, if it was a Cl, it'd be a triangle Cl, and it is positive. So far we've had halogenation, which is basically this, but you're adding the Br minus. That's been a positive charge, and this has a positive charge triangle, and so does oxymercuration, demercuration, which I didn't draw in that video, but I told you how to quickly find the product. So what happens is that it's still anti-addition. Anti. So that means one has to be wedged, one has to be dashed. So if you have a Br ring that's both wedged, you have to have that remain wedged, and that has to, your OH adding has to be dashed. You know it's OH because it's like H2O. Okay? In the HGOAC, the oxymercuration, demercuration, you have to keep an eye on beside the HgACO2, whatever it was. If it was water beside it, an alcohol. That's the same connection right now. You have to keep an eye on what's underneath the arrow. If it's water, you're adding OH. Anti, of course. And if it's an alcohol like methanol or ethanol, you're adding some kind of OME, or OCH3. If it was ETOH, it's OET, or OCH3, CH3CH2, right? And it's going to be anti. That's all that happens. If this was CCl4, fine, then I would just add a Br anti. If it was Cl2 and it was CCl4, then I would just have a Cl anti addition. So this example, how we quickly find the answer is that, okay, my OH, whatever, is always going to attack backside the most substituted, always. So whatever it is, I'm going to get that, wedge or dash. In this case, it's water, so the OH is going to be on the most substituted. In this case, it was symmetrical, so that's a bad example. Here's another example of an asymmetric alkene or double bond. I add my alcohol group to the more substituted. Because the thing is, when you form that positive triangle, you can argue that if it has more groups attached to it, it has more carbocationic character, it's more stable. Even though it's not a full carbocation, it's partial positive, because there is that Br that's pulling electron density. But the more R groups around it, it's donating more electron density. So point being is, you just have to remember that whatever your nucleophile is, whether it's water, because that's the solvent, or if it was CCl4, the halogen itself, will always add to the more substituted side. Okay? So water adds to the more substituted side, alcohol would add to the more substituted side. It's going to be anti, so if that's dashed, your Br that formed the ring has to be wedged. If this is wedged, the Br that formed the ring has to be dashed. If there's another group that was, the other group just has to oppose whatever this is. If this is dashed, the other group, this methyl group would have to be wedged. If this OME is wedged now, that means the other methyl group hanging out in that carbon has to be dashed. So that's halohydrin formation, anti-addition, the nucleophile, which is a solvent. CCl4 has no basic or nucleophilic properties. We'll add a more substituted carbon, anti-addition.